1.8 Limits of piecewise functions. For each piecewise function, determine the value of the following limits. Remember, piecewise has the pieces. It could have as many as it wanted. All of these will have 2. And we're trying to find a right or a left-handed limit. You're only going to use the piece that you need. And before we start plugging stuff in, I want to graph this, just remind you what piecewise looks like and how you graph it. Then hopefully that will make it make more sense when there's no graph. All right, so for this first piece, this piece only exists for x values greater than -3. So if I were to make a table, I would pick some values greater than -3, which would be like -2, -1, 0, and then we plug them in. So when x is -3, -3 squared is 9, -10 plus 9 would be -1. When x is -2 squared is 4 plus -10 is -6. -1 squared is 1 plus -10 is -9. And then when I plug in 0 squared, 0 plus -10 is -10. That's good enough for that one. And then now the second piece, if I make a table, it only exists for x values smaller than or equal to -3. Which means there will be a closed circle on this one, but an open one here. So closed here, open here. Okay, let's plug in -3. We would have a negative of -3, which is 3. 3 minus 7 is -4. Then we would have -4. So a negative of -4 is 4, minus 7 is -3. -5 would be a -5, which is 5, minus 7 is -2. That's a linear function, and this is quadratic. So you should know what those look like. Let's graph it real quick. We're going to have a point at -3, -1 with an open circle, -2, -6, -1, -9, and 0, -10. So this piece, this is a quadratic, would be like that. Okay, linear would be -3, -1, 2, 3, 4, closed, -4, -3. So it's just going up 1, right? Or down 1, really, because this is a negative slope this way, but I'm working to the left. So it would be closed point like that. And I actually pulled it up and graphed it on Desmos, and it looks like that. Okay, so when we're evaluating the limit as x goes to -3 from the left, then this is where the break is happening, is at x is -3. But coming from the left would be this side only. So which piece is that? Is the piece that's going to have x values that are less than or equal to -3. So we're only going to use that one. Okay, so all I have to do is plug in -3. So negative of -3 minus 7. That would be 3 minus 7, which is -4. And we already found that out because there was a point there. So you're just finding what is it approaching. All right, so number 2, I'm not going to take the time to graph it. We're trying to find what's happening as x approaches -3 from the right side. So these would be for x values greater than -3. This is for x values less than or equal to -3. So we want the side that's coming from the right. So we'll use this one. So I would plug in -3. That would be -12. 6 minus 12 is -6. Here's a graph on Desmos. So I'm looking at the blue piece, which was my right piece. As I'm getting closer and closer, see how I'm here at -3 comma undefined. So that's where the graph doesn't really help because there's an open circle. But if I look here, I'm at or approaching -6. All right, then the only other thing we need to talk about is what if it's a two-sided limit or a general limit? You have to use both pieces to see if the general limit exists. So we're going to check when x is approaching 3 from the left and the right. So let's write it out. The limit as x approaches 3 from the left and the limit as x approaches 3 from the right. which piece are we going to use when x approaches 3 from the left? That would be the one that has x values less than 3, so it'd be this one. So -4 plus 2 times 3 would be -4 plus 6, which would equal 2. And then this one, we're going to use the one for x values greater than 3, which would be 3 squared minus 7, which is 6, minus 7, which equals -1. Because these don't match up, this is a D and E. Sorry, I'm off the paper there. And I just caught my mistake. That's a good thing about graphing it to check. I graphed it and I thought, hey, they do meet here at 3, undefined, but it's at what, 2? Because 3 squared is not 6, it's 9. So I don't know what I said or what's happening. 9 minus 7 is 2. So it's not D and E, it's 2. Okay, I want you to try number 4. Okay, checked it this time on the graph, so I know I did it right. The limit, as x approaches -1 from the left, you get 6. So see this piece up here, and then the right piece, you're getting -6. Those are not the same values, so the general limit does not exist.